So, good afternoon from AT for this webinar today. And our title is today ECS, cost-effective 3D sensors with a large field of view. So ECS is our economic compact sensor, and this is just one topic what I want to mention today. I want to give you a rough overview about our big portfolio in 3D sensors and as well of our software. So my name is Armin Jehle. I'm a senior sales manager at AT in Europe, and yeah, I'm more than 25 years in machine vision area. A lot of the time at Cognex, but also was working for a system integrator and as well for another 3D vendor. And yeah, so you see, 3D got more and more important the last 10, 15 years. And all the time I was looking to AT because AT has what I need for customers, for projects, maybe faster sensor, bigger field of view, more resolution, dual head, different laser option. So since 4 years, I'm part of AT and now I have it and I'm happy. Yeah. Some news regarding AT. So, AT automation technology is really long. And also in the past, we had complete solutions with NDT, with infrared cameras. So now we are focused more on sensors in infrared and as well as in 3D. So we do a rebranding. So we find us in the future as AT Sensors. And we do the celebration one month ago. So, and you also can see the new website as at-sensors.com. A little bit shorter. And so you know it's not a new company, it's the old company, automation technology. So what is behind AT? So we are located in northern Germany between Hamburg and Lübeck. It's called Bad Oldesloe, and maybe you heard in the marketing videos, hello for Bad Oldesloe. So, and we are more than 25 years in the market with infrared and 3D cameras. We are around about 55 people, and we are developing, producing, and selling cameras in special areas. One, as I mentioned, is infrared. There we provide smart cameras with a special app and job concept. And another bigger one is the 3D area. So in 3D, yes, we have a lot of a bigger portfolio. We have offices in Germany as well as in US, and we are worldwide with our distributor channel and partner channel available. So some USPs from AT regarding the 3D sensors. So yeah, we're always one of the fastest or the fastest sensor company. And you see there up to 200 kilohertz. This is with our 1280 sensor. And yes, for sure, this is depending on which set range you are using. And maybe you heard the warp speed. Now, warp is standing for widely advanced rapid profiling. This is a special new imager which we are developed, and I will come a little bit deeper in another slides. So we have a big range of images starting from 1280 pixels per profile up to 2000, 3000, and 4000 pixels. So you can do also some really high precise metrology applications. We have a big portfolio of lasers which you can use, not only different wavelength and laser class. Also, we can choose maybe the right laser depth of field or the laser line thickness. And with our modular sensors, we also can provide single dual head and take all components of all what we have in one sensor. So on the right side, maybe you see a little bit some images of some sensors. We have a big portfolio, and starting with cameras, this is available with all images. And then we have a really big portfolio of standard compact sensors. So around about 35 sensors multiplied by different laser options. So we have more than 150 different sensors. And if these are not flexible enough, we can have our modular compact sensors and do really the right sensor for the application. So, and our customers say, yes, if I use AT and you optimize the sensor, I cannot do it better. And once AT, you will always have AT. So out of these standard sensors, we created a new series. It's called ECS, standing for Economic Compact Sensor. Because maybe there are a lot of applications which are maybe price sensitive, and you want to do a measurement, but you don't need maybe microns, maybe just a half a millimeter to do that. So we created an easier sensor. In this case was the first sensor with 2000 pixels. It's also still really fast with up to 25 kilohertz. And there are two sensors with 100 millimeters field of view and 160 millimeters field of view. We choose the easiest and maybe the cheapest laser with the red 660 nanometers laser, and it's only available in 2M. This brings also some advantages. You know, you don't need special laser safety actions, and we are targeting, especially, for example, you see here on the this image some pretzels. We go to food market, logistic, robotic marking, and then you need maybe just an easy sensor and don't need a lot of stuff to do the laser safety. It's a standard interface. We have the GennyCam. So if we have a software which talking with GennyCam, it's quite simple to integrate the sensor. So and this was the first series in Q1, and now this was yes the title. We come out with another sensor, ECS with 4096 pixels. So it's high res and still also fast with up to 25 kilohertz, and with a bigger field of view. Now you see here we have 284 millimeters or 555, because we saw maybe in this food and logistics you have maybe a bigger conveyor, you need more resolution, and you need more sensors, and so it will be a big advantage to have a bigger field of view. So what we can do with that, some applications which we are targeting. Yeah, for example, for packaging, yeah, we are doing the position. We need X, Y, Z, and also the rotation. We give this data to the robot, and then you can do a bin picking application or a picking application. And very often also for measurement, you need the position and also the volume of the package. This is quite simple what we can do. And also, for example, some surface inspection. If you want to have some defects of these packages, no? You also can do it. Maybe not with one sensor, but with the application, you do it like here. We have two sensors mounted as a V, and then you can get a position. You get also the defects around of the package, and it's quite simple to do maybe a multi-sensor application with 2 or with 4 sensors, and also in combination with our metrology package, which I will introduce a little bit later. It's quite simple to get one point cloud out of multiple sensors. So, and how it look like with a multiple sensor application? Yes, quite simple. You have the conveyor belt. We get the encoder signal. We can give the encoder signal to each sensor, or we can have a a master slave application. So one sensor get the trigger and give it automatically to the other ones, so that they don't influence each other. And then you get the images to per gig E to the PC. And that's also what I want to mention. So AT is only providing triangulation sensors and only PC-based sensors. So we have no smart cameras where I can do the complete application on the sensor, because AT is well known as a high-performance sensor company in terms of speed and also of resolution. So again, it's all running on the PC. You have your application, and then you can maybe connect to the PLC or to the Profinet, for example. So this is the entry level, the economic compact sensors ECS. So now we go to the high end, and AT is developing their own imager. And normally, imager is acquiring an image and then is transferring all pixels from the imager to the FPGA on the sensor. So we go another way, and with this new imager with 3000 pixels, so it's called 3070, there is a pre-processing. This means we are directly detecting on the imager the laser line, and then we transfer only the pixels around of this laser line from the imager to the FPGA. This means less information, and then you can achieve a much more speed because it's much faster to transfer this data. So, and with this imager 3070 and with our new FPGA of the C6 with a double speed, and in combination with the new interfaces which have N-base-T and can have 2.5 gigabit and 5 gigabit per second, that they get all data from the sensor also to the PC. This is what we call warp speed. Then you can achieve the warp speed. And this is standing for widely advanced rapid profiling. So with this imager 3070, which is available in in the cameras as well, and also in the modular compact sensor. This means all what we have, all images, all lasers, all optical setups, and so on. This can be put in a modular compact sensor, and do the sensor optimized for the application. You can see on the right side is one example. So we have a sensor module, we have a laser module, and then we can double it as a dual head, and then you have two sensor modules, one laser module, and depending of your data which you insert, you will have a spacer in between. But you can have a customized sensor. And how does this work? So we have a modular compact sensor as a configurator, and you have at least maybe the sensor module with the imager, with the optics, with the lens, with the Scheinflug. And the second one is the laser module with the laser. And depending what you are inserting in this configurator, like as the field of view, the laser distance you need, maybe of a minimum laser distance or maximum, what your minimum need, the triangulation angle and all other data, there is a sensor coming out. No? And you can also choose a single or dual head. Then as I said, you do double the sensor module. We have two sensor modules and one laser module. At the end, you have a customized sensor. And yes, this sounds expensive, but it's not. So we have no additional engineering costs or minimum order quantity, but you get at the end optimized sensor for your application. And our customer ask, so it's not better. I cannot do a better sensor for my application. No, that's it. So that's the reason why if we are in, we stay in. So, and with this modular sensor concept, we also have the high-end sensor. It's saying for XCS, standing for extreme. This means we are using an MCS and optimize that regarding speed, resolution, and so on. It's available with the warp speed, means really fast, and as well also with the 3070 and the 4090 pixels. And this big resolution with a big chip, we'll bring it with a special optic to 48 or 53 millimeters. Means really high resolution on a small field of view, optimized through the optic. This is one point, and another point is you're using a special laser with a really thin laser line in 405 nanometers in blue with the clean beam technology. And this is especially for applications in electronic. You see, for example, here a pin grid area or a ball grid area. So you have really small pins, and also to avoid the reflections on the pins, you need really a good laser, a small laser line. And in this case, we can achieve really high accuracy and also by high speed. And with this speed, we're able to go to electronic market before maybe the laser scanners and the laser profilers were too slow. So this is a new market for us. And at the end, yes, this is the high speed model which we are providing. So this was a small overview for the hardware, from economic compact sensor as an entry level up to the XCS. And yes, we are providing the images, the 3D images. We can providing the point cloud, and we also have a software available. It's called the AT solution package. So there is the SDK included. There is online documentation included, and also as well our metrology package. We have this since last year. And in this metrology package, there's also a metrology explorer available. And this is really a easy graphical user interface to get really fast images. This means, yes, you can connect to all cameras and compact sensors which are available in the network. And then you insert all parameters which are necessary to acquire an image, like as exposure time, gain, the encoder signal, where the trigger is coming from. And then you can really fast get an image from your sensor and to see if you can see what you want to inspect or what you want to measure. And then what we say, yes, within 10 minutes you get a first image. But this is more. This is also a software bundle. We have software tools for fast prototyping. This means you can use the samples to start with that. You have 3D tools to do the application, 3D application. And if you want to use these 3D tools, and if you want to develop a complete application and get out the source code, we can provide a development license. But a lot of things are still available for free, like this Metrology Explorer. And also really important is the calibration. So as you know, our sensors are calibrated intrinsic along the laser line. This is the X direction for us along the X field of view. But you also needed a calibration along the transport direction in Y. And also if you have a dual head, you need, maybe if you want to have one image, you get two images out of the sensor. And if you want one image, you need a calibration. You can do it with this calibration plate quite easy. And then at the end, you get one point load out of two sensors. Or also multi-sensor registration is quite simple, easy, like here in the V with two sensors, or also with 6 or 8 sensors. And you see in this case, there's two sensors, two different wavelength, blue and red. You get two images. And with this calibration target and with the metrology package, it's quite simple, easy to bring these two point lights together and to have one point load out of two sensors. So this is one example. We showed that on the Vision trade show. So it's a free fall demo with golf balls, and you can see how this works with the sensors. And in this case, it's fast, yes, but also our 1280 sensors are fast enough to get this golf ball. And we are using four sensors, two with red, two with blue, and with a master-slave configuration. Means one sensor, if we detect the part, we're starting to acquire the image and also triggering the other sensors. So in the end, you see there's one golf ball. It's round, but you still get a really good point load out of that. And we also, there was another opportunity to put in maybe some sweets here. In this case, it was a chocolate bar. And you can see the point loads. We used here different colors, 4 colors for each sensor. And you see how it comes together and how we do the stitching. So this, at the end, it's maybe it looks really simple. It's simple with the metrology package, but everybody who is programming software and doing the calibration and a lot of stuff like the coordinates, bring it to another coordinate system, it's really complex. So you can use our point clouds to the application by your own, or you can test maybe this metrology package. And if you think it's an advantage for you, you can use it. And also work with your other third-party libraries or with your own software. And at the end, it must be fast and really a robust and good application at the end. So a little bit applications out of the field. This one, nice application which I showed in other webinars. It's coming from our partner SenseWork, and this is an inline metrology application. And in this case, we are using 4 modular compact sensors optimized in field of view, in working distance. We optimize the lasers. You see there are two laser colors, two wavelength. We optimized that in the depth of field of the laser. And then we use the metrology package to get one point load out of 4 sensors. So you see this point load, and then this point load is compared to the CAD data, and you have some special points where you want to see the measurement, and if it's all is in green, it's all fine, and all measurement data are in range and in tolerances. So this is really, it looks quite simple, and it's more and more that the customers need an inline application or inline measurement application. So, and before the customer uses it offline and needs maybe 4 to 8 hours to get the results, in this case, he needs only 8 seconds. Another application from our partner AKU, or a system integrator in Germany. So this application was some metal parts, some gear parts. In this case, you see the calibration target, and it was necessary to have a 360 degrees inspection. And therefore, they used 3 sensors, MCS sensors as a dual head. And with the software and the framework of AKU, it's called Vision Manager, they are doing the one point load out of the 6 sensors. And then they are using third-party libraries like Cognex Vision Pro or Helcon or Metrox to do the application. And maybe last but not
1 minute
least,
left.
another application. This is for marking of small parts, and the sensor is here as a dual head. We have to measure the height. We have to get the position and send the data. You see, it's maybe just 100 millimeters, and then the marking laser is coming. So we have to really be fast to detect the part and send the data X, Y, Z rotation to the sensor, to the laser marking system. So a lot of information in a short time. AT sensor standing for performance. So I also provide this performance. If you have some questions, you can come to us, or maybe you have 1 minute left, I guess, no?
So it's now or never. And Armin, first question is it possible to develop a solution with ECS and move to other 3D sensors?
To other, yes, but only from AT, yes, for sure. So this is the same interface. If you do the interface once time and with your software, you can use it for ECS as well for all MCS or the XCS. And also with the metrology package, you can use it here. And maybe if you see you need maybe more performance or you have to choose something, you can use the software which you are developed with ECS also for standard or for MCS sensor. So it's compatible, yes.
And how are AI solutions addressed at AT? Are there already examples of 3D applications that are evaluated with AI?
Yes, there are, but yes, we are providing the images in this case, and then you can use the deep learning software from third-party vendors. This is what we done from our OEMs or also from the system integrators. No? So we are providing the images. We have when we can do the measurement, but the images can also go to another AI software to do maybe surface inspection and so on to find parts or scratches and so on, which you don't know where they are.